Put gin in this one. Yeah.
Warm water.
And soda water. The gin one, really.
Oh, gin, like
Gin.
gin. Oh, gin. Ginger. So nice.
I've never in my whole life come to a job drunk. I have had a few beers before work at times, you know, drought. and about.
First time for everything, Patrick.
That's right. Well, for some reason, I take teaching seriously. I don't know what's got into me. So I'm going to start with a little bit of the lesson tonight, which is on going from plans to buildings until maybe 6:30 when I'm sure everybody's here. Then we'll do the prep, make sure we get it, and then we'll go back to this, okay? Because the prep's important, but I know if I start in 15 minutes, someone will come. So let's do it that way.
Hey, the camera looks like 10 degrees skewed. If
Oh, yeah, this way. So you can tilt it up like that. Does it make you seasick, Zach?
it's a little weird. I feel like I could get used to it, but it is a little disorienting.
No, not quite. Well,
She's weird. How do
yeah,
I?
the board, just do the board. It's parallel to the bottom of the screen. I guess that's the trick.
That looks good.
Okay.
Thank you.
So you're lucky we don't have a lot of time in this course because I'd have you do more math. So we're just going to do a little bit tonight. So you should, I think it was your last handout, but I'm not positive. On the very last page was a list of construction material units. Zach?
Yeah.
This handout, the last page of it, I'm not sure which one it was. Last one?
Last two,
What about it?
Yeah, that we're going to look at that.
Oh, okay. Thank you.
And I have brought some extra. Just some extra ones right here. Everybody got that? Okay. So talk about plans and to do takeoff. Takeoffs are like estimates, right? Material estimates. They're called takeoffs. Could be a labor estimate too. But right now we're talking about a list of materials, you know, for the job. So I did a sheet of sample units and some math formulas for, you know, if there's a quantity involved, how to find that quantity quickly. So let's just go through some of this. For instance, so it's got the area like foundation, floor, walls, and then it's got the material, whether it's wood or sand or fasteners. It's got the object, what we're making with it. And then it's got the unit. And then it's got a formula if there's a trick to the units. Like some of the units convert the cubic feet to cubic yards. So it's helpful to know those kind of things. And then just finding areas, just review that quickly. And then there's one that involves footing, cross sections of footings. So foundation, if you order, whether you're doing a footing or a raised foundation, you're going to pour concrete, and you're going to order concrete by the yard if there's enough for a truck. So a truck will come from the local concrete company and they have a minimum, I think it's 2 yards, where they won't charge, they just charge you for the 2 yards. If it's less than 2 yards, they tack on they either charge you for the minimum, even if it's less, because they have to bring a truck out. So, but so you find the yards. Say you're doing a slab. So slab's easy. Slabs are basically a rectangle. It's got width and length, and then it's got a thickness. So it's a 3-dimensional rectangular solid. And so to find the volume, we're going to multiply each of those dimensions by itself. So there's a slab, say it's 6 inches this way, and 3 feet this way, and 6 feet this way. So now you can't multiply feet by inches, or you should know that. So we have to either convert everything to inches or everything to feet. So I'm not going to do much of this tonight. In the math class, which we're not having this summer, I got 0 response from people. I sent out 2 emails, so we dropped it today. So it's going to be offered in fall. And I don't know if I'm going to teach it or not. But anyway, we do a lot more of this in there. This is pretty critical. People have forgotten their geometry and their solid, their volume and area formulas and stuff. So we're not going to go through a lot of it tonight. This is pretty simple volume. So most people, I think we're taught in math to go with the smallest unit. So you go with it, you convert everything to inches, which would be the smallest. But then you're dealing with 72 inches, 36 inches times 6. That's a lot of multiplication. You have calculators, you could do it. But one thing I always teach my classes is for slabs of any kind of rectangular solids that are thin, like 2, 3, 4, 5, 6 inches, make the inches into a fraction of a foot. And then you can multiply these 3 together and it'll be a really low number. Like this is 3 times 6 is 18, and half of that is 9. So it's 9 cubic feet. It's a lot easier than going through all the inches, multiplying it, and then dividing it at the end by 144. Okay. So the big thing is, area is, and especially a slab, length times width times thickness, any kind of volume set, rectangular volume set. And then all you have to do is make sure your units are the same. So go with feet if you can. If this was 4 inches, it'd be a third of a foot. Third of 18 is 6. I mean, it's so simple. If it's 3 inches, it'd be a fourth of a foot. A fourth of 18 is going to be, half of 9.5, whatever that is, 4 3/4. So it's an easier way to do it. Just keep that in mind. If you take the math class, we'll do much more of this. So that's going to be cubic feet, yes? Let's say this was half of 18, 9 cubic feet. Now, if it's small enough like this, you wouldn't need a cement truck for this. So you would go to Home Depot and get cement bags for it, right? Maybe 20, 30 bags. It's a lot of bags, but it's still cheaper and easier than getting a truck. You have to schedule a truck, all this stuff. So in Home Depot, the bags there's 60 and 90 pound bags of concrete. And they used to have the cubic feet written on the bag. They do not do that anymore. They have a little table on the back that says, if you're pouring a slab that's 3 inches, it's a table 3 inches thick, 6 inches thick, whatever, and then it has the width and length. Then it tells you how many bags you need. It's really stupid. They dumbed it down because people have forgotten how to, figure out how many square feet, cubic feet they need, and then figure out how many in a bag. Right? So anyway, that's what you do if you're making it yourself. If you order a truck, they'll do it in yards, cubic yards. So there's a formula for how many cubic feet are in a yard. And you know what it is?
Right here.
It's on the page here.
Yeah.
Well, that's good. See, that's another smart thing is teacher asks questions, quickly look over any kind of handout. Often the answers are there. So if we want to know how many cubic yards this is, we divide this by 27, right? So that'll be a third. So a truck doesn't want to deliver a third of a yard. I don't even know if they'll do it. You know, it has to be closer to the minimum, but anyway, that's how you'd figure this. If this was 540 cubic feet, it would be 20 yards. We just say yards, we say cubic yards. Okay, see that? So that's pretty straightforward. Now there's a so if you have a foundation that's a footing in a stem wall, right? Everybody got this? Can I erase this? When we do the in a few minutes when we start on the prep, we'll look at the math problems and we'll see the example, and I'll make sure you know how to do it. There's only a couple. There's only a few. So nothing to worry about. So you have a looking down plan view. You have a house, and you have, well, let's get it this way too. You have a footing. This is the cross section. You have a footing. You have what's called a stem wall, and then your floor system goes on that. The ground's usually somewhere right here. It can't be deeper than that. More like this. So you would figure the amount of these separately. Figure this size and this size, or you could figure the square footage of that by knowing that. Say this is 6 inches. This is 6 inches. This is 2 feet. This is 2 feet. And this is 6 inches. So this bottom one, the area would be 6 inches times 2 feet. Same units, it would be half a foot times 2 feet, should be a foot. So that's 1 square foot. Bottom part, footing. The stem wall is a half times 2, which is the same thing, right? So that's another foot. So this whole thing would be 2 square feet, right? Is that right?
Yeah.
So that's an area measure, not a cubic measure. But so if we cut a line in that perimeter, it would look like this, right? Cut a section of it. And if you were looking at if you're looking at from the air after the concrete was poured, it would look like this, and then you'd see this little bit sticking out, right? It's 6 inches sticking out. You might draw like this so you don't get confused. If this is not confusing. So in order to find the cubic, you're trying to find how much concrete you need for this foundation, right? This raised floor foundation. So what you're going to do is instead of length times width times thickness that we did for the slab, this is simpler. If you take this area, the volume will equal that area times the perimeter. So say this is 20 feet and this is 30 feet. Now there's overlap, right? So this will not be the whole 20 feet because, you know, the corners, one will run long and one will run short. But when you're ordering concrete, it's always best to be a little over anyway. If you're under in a truckload of concrete and it doesn't have enough to finish the foundation, that guy has to go back and get concrete in a hurry, because if it dries too much, then it's called a cold joint. The wet concrete doesn't integrate, and they can make you tear the whole foundation out if you have a cold joint. So you don't want that. So you either have some concrete by hand on hand, or you order a little 5% more to make sure that doesn't happen. So if we're making this, then by not counting that overlap, we're getting a little bit more anyway, so it doesn't matter. We don't want less than that. So the perimeter would be 20 and 20 and 30 and 30, right? So that's 30, 30, 60, 80, 100. So the perimeter is 100. That's linear feet. The area we said was 2 square feet, right? So the whole volume of that would be 2 square feet times 100 feet. And that'll give us 200 cubic feet. That's pretty straightforward, right? When we look at the problem on the exam, I'll look at it. Maybe we'll do that again, or I'll give you more clues. But basically, you want this formula. It's the same as length by width by thickness, but we're making the area as a unit because it's easier just to find that cross section in the area, and then we're taking the perimeter as the other separate dimension.
Patrick,
Yeah.
for the sake of the exam, are we going to do it just the way you did it, or should we take care of the corners like you were saying?
No, I'll say don't worry about the corners.
Okay.
We'll go over it. I'll read the actual problem.
Okay.
So if you go down to floors on that sheet, and then under wood, there's sheathing at the bottom. You see that? So when you get done with the floor, you get done with the joist, you're going to put sheathing on it, right? Plywood. And so under floors and the object sheathing, it says a piece of plywood or OSB oriented strand board. Those are your flooring. And then it says the number of sheets would be the whole area of the floor divided by 32. Anybody know why we divide by 32?
That's the area of the sheet of plywood.
Yeah, a sheet of plywood is 4 foot by 8 foot. It's 32 square feet. If we have a house that measures 160 feet, or building by 20 feet, what's that?
120. No,
3200, right?
3200.
So then we would divide that by 32, because each one of those sheets is 32, and we get 100 sheets we need for that. Now, so you take the area, the whole area of the floor, or this could be roof, anything where you're putting sheathing on, or wall. You take the whole area and you divide it by 32, and that tells you how many sheets. Now, that's not exact for several reasons. If there's certain lengths, and I didn't take the time to tell you what they are, where you can't, you start with a whole sheet when you're laying out the sheathing, whole sheet, and then at the end, whatever's left. It may not be a multiple of 8. So it could be 2 feet left, or 4 feet left, or 6 feet left. If it's 6 feet, you just have to use a whole sheet and waste that 2 feet. That's all there is to it. If it's 4 feet, you can use a half and then start the half of it. You should stagger it. So if it starts at 8 feet, the bottom of the floor, at the first part of the floor, then do 4 foot for the next one. I'll show you that. But sometimes you have 2 feet left on the end. If it's multiple of 8 plus 2 feet. You can't put a 2-foot piece on a roof because that's one bay. The bay on a roof is usually 2 feet on center. If they were 16 on center, you couldn't put a 16-inch piece because the wind will blow that off, or the earthquake will blow that off. You need 3 studs underneath the piece of sheathing to make it weatherproof. So you would have to go, if it was 2 feet on center, which most roofs are, you have to make sure at least with a 4-foot piece on the end. So in that way, you may waste more than that exact number, right?
Mm-hmm.
So what I do, if it's a small roof, like say it's I did a 20 by 30 roof. And you're going to have joists come like this. Usually the joist will go the narrow dimension. So that means your sheathing is going to go across the thing. So this is 20 and the 4 feet, we get 5, right? So your sheathing is going to run in rows like this. It'd be 5 rows that way, and then this is 30, so it would be 8 foot this way, so that'd be 3 of them. 24, and then this would be 60. So this is, each of these is an 4 by 8 piece of plywood.
Okay.
So If you made a grid and counted all those, what would you get? 1, 2, 3, 4 times 5, 20. So you need 20 sheets for that, right? But let's do it the way we just figured. So 20 times 30 is 600. Is that 30? Yeah. The area is 600. And if we divide that by 32, what do we get?
18.75.
18.6?
18.75.
Yeah, so if we did that and we rounded off to 19 and got 19, we'd be one short. So the formula is the most efficient, mathematical formula gives you the most efficient quantity, but roofs are not always that way. So my suggestion always is to draw the roof or by count. And if you have a problem, like you have 2 foot, say the roof looks like that, then you got to come back 4 foot. So then you have to have an 8 foot. So, you know, if you have a 2 foot, then you have to redistribute the lengths of those. And you can just do it on your drawing, and then you'll still know what you're going to have to order.
Is it worth it to design on 4-foot modules for that reason? Like if you were an owner builder and you just kind of had your way.
Now, a floor is pretty easy to do on 4 foot modules, but a roof has an overhang.
Mm-hmm.
And it depends on how the rafters are laid out. If they have the overhang like an even 2 feet, which is a pretty big overhang, it all depends on the look of the house. Then you could make it 2 feet to the wall and then 2 feet on center all the way across. If the building was a multiple of 2, you have 2 feet on the other side. That'd be hard to do, but you could design that.
Mm-hmm.
And that's what the advanced lumber or advanced framing people are trying to get architects to do. So it works out in some ways. The roof's the hardest thing to do. You could do it, but most people just, if they waste a few feet on the roof, they don't worry about it because roofs are tricky anyway.
That makes sense.
Yeah. Okay, so then the other thing is turn this thing over, and on the roof, I didn't include it, which is really pretty funny, but the last material is of course shingles. that's the main thing. But
You didn't include it, you say?
yeah, so after miscellaneous,
Mm-hmm.
I just put shingles down there. Just write shingles in, or composition shingles. After miscellaneous, on the back of this, under roof, in the roof section, at the very bottom of the roof section, it says cover and then miscellaneous. Under that, put shingles. So the reason I'm including this is shingles have their own quantity designation. So shingles are sold in square feet, in squares, they're called. And a square is like 100 square feet of material. So every square of shingles will cover 100 square feet of roofing. Now, the weird thing is you don't buy square, you pay for squares, but you end up getting bundles of shingles, right? And there's so many bundles in a square. So that's even more complex. But when you're ordering it, you want to make sure you have enough shingles. The lumberyard will convert the squares to bundles because they're going to sell it to you. So you tell them how many squares of shingles you need, and they'll tell you how many bundles. They'll put the number of bundles down. So if you had a roof that's 100 square feet, say it's
1 square.
yeah, it'd be 1 square, right? That's a small roof, 110 by 10 little shed. So it's 100 square feet, and 100 square feet equals 1 square, so it'd be 1 square with the shingles. If you had 1,000 square foot roof, it would be 100. It'd be 1,000 divided by 100, or 10 squares. So a square equals 10. A square as a unit of measurement equals 100 square feet of area of shingle. Okay. And the only other thing before we start, well, no, we got some other stuff. Yeah, we're doing pretty good actually. There's some questions on wall layout, and they have to do with ordering. So when you have when you have 16 on center walls, which are quickly becoming obsolescent, but we still build them. So they're 16 on center, right? They have to be 16 on center. So an 8-foot wall is 8 times 12 feet, 96 inches, right? So how many 16-inch, how many studs on 16-inch center will be in an 8-foot wall? So you could take 16 and divide it into 96, right?
Mhm.
What does that equal? I don't hear Zach.
That's 6.
Yes. So so this is the same thing as the sheathing. The math may not be exact. So let's draw out an 8-foot plate. So those are 16 inches apart. This is looking down at it, right? So we said it's 96 feet long and they're 16 inches apart, so we need 6. But look at this. So there's one on the end, but you're not counting, you're really counting the spaces, but you have to include that one. So whenever you divide by 16, always add 1 to that answer. So if it's 6, like we did, and add 1 would be 7, take 7 studs.
This is, you're calculating studs, right? That's what, or the
Yeah,
point
yeah.
of this.
So if you're trying to get studs off your length of walls. Now, the other thing is, you're not going to draw every wall and put studs in. That's, that would be too much work. So the rule of thumb for 2x4 wall, 16 on center is 1 stud per foot. So the studs are 1 foot 4 inches apart, right? So you're actually you must be including several more studs in there to get 12. And you are, because what do you have in a wall? You have windows and doors, right? And sometimes it used to be the corners of walls might have another piece in it. Advanced framing doesn't use that, but even with advanced framing, you'd still have trimmers, which are full-length studs for the windows and doors. And you don't know how many are there, but the wisdom is in a whole building, all those extra studs would make it equal 1 per linear foot of wall. So if all the walls add up to 200 feet, you can get 200 studs and you probably be on the safe side. That's how they do it. They have little formulas. People that have big companies and have done this for years, they may have a number besides 1 per foot. They may have a little formula that they use based on their experience. But it used to be, we would just count 1 per foot and that would work. Now, 2 foot on center studs is easier, right? So say you have an 8-foot wall, how many 2-foot spaces are in there? 4. There's 4, right? So would we need 4 studs? 1 more, we need 5 studs, right? But those are easy to put because you just have for every length of wall, you take half as many studs as the length. So 20-foot wall, you take 10 studs plus 1, you take 11 studs. So you figure it differently. You don't figure 1 per foot, but you divide up 2 feet in. You divide the linear footage by 2, which is the same as dividing 2-foot lengths, and then add 1 for the inline. Okay. So those are just formulas to get from the length of your walls to how many studs you'll need to build. So the only other thing is keeping your wood straight. You get a lot of lumber from the lumberyard, right, to build a house. I mean, sometimes, usually, I don't know how people do it. Maybe some of you guys that are working for general contractors now can tell me. They used to do it different ways, but they used to divide up the orders and you wouldn't get everything at once. It depends on how complex the house was. It would take several weeks. You'd separate over that time so you wouldn't have all the wood on the site sitting in the sun, maybe in the rain. But a small home, they might deliver all the wood at once. And the trick is you've got to separate the wood into the piles. You know, you've got joists. Sometimes you have joists that are the same width, but they're different length. They could be just slightly different length, like 8-footers and 10-footers, 10-footers, 12-footers. So you've got to know where they go and mark them. You know, just put a mark, a piece of tape on them. These 8-foot 2x8 studs are for the bedroom ceiling, See, that's one thing you've got to do when you get the load, because they're not going to put it on any order. They're going to go to what they're going to do is they're going to take your takeoff and they're going to look at how many 10-foot studs how many 2x4s at 10 feet there are all together. So they're just going to go get a pile, and you're going to get a big load of 10-foot 2x4 that may go for many rooms. So you've got to separate all that out. The other problem with separating that is if you're getting multiple lengths from a certain length, like say it's cheaper to get two pieces, like a 6-foot and a 3-foot piece you need for short joist out of a 10-foot. So you order a bunch of 10-foots. You've got to remember that those 10-foots are being cut into 6 and 3. But then you've got other 10-footers that need to stay whole for joists. So you might get the same width wood, some of which stay whole and you're just going to cut a little bit off. Others you're going to split into two or three pieces of wood. So that's another thing you got to get straight when you get those. And it's very easy to get confused. Start cutting all the 10-footers and go, oh crap, I just cut my joists. Right? I thought they were all smaller pieces. So those are just tips on going from plans to the order to the delivery to how you're going to start building. The other thing I mentioned before, and I think that's all we're going to talk about now, and then whatever else we'll cover it on the prep, is short and long walls. Remember we talked about that before? Like when two outside walls meet, one's a short wall and one's a long wall. One goes past the other one. The plans to show it like this. So they don't tell you which one's short or long. They're not going to commit to that because they're not builders. They don't want to mess with it. So they just give you that. So you have to figure out. So when you're measuring the plan, there's different reasons for why you would have a long and short. And those are just things you have to know. It could be that if you run it short, you can get all of that out of a certain, almost exactly 10 feet. And if you run it long, then it's going to be a little more than 10. You have to go to a 12-footer. So the size of each of those walls may dictate which is long and which is short. On a second floor, you're usually going to build the outside walls first, because then you can build the inside wall and push it up and sort of wiggle it into place. You know, it's a drop off here, right? It's a floor or two down. If you build this one first, well, that would be okay too. Yeah, you could do that too. Because just make sure you build the last one first, the last one. Oh, what I'm saying is, if this outside one runs long, you don't want to build this one first. Because then you've got to build this one sideways and turn it into place. And that's just, you couldn't do it. You have to hold it up over the air to get it into place. So that has to do, so that'll help determine which is long and short too. So probably someone on your crew, could be you or, you know, will be looking at the plans and will make that decision for those various reasons and mark on the plans which are short and which are long. So when you go to build the walls, you can just look at the plan and it'll have a mark and you can just measure that. Say, okay, this wall's 10'6". That's where we're going to build it. Or they may do it. The person making that decision may actually write out the size of the dimension of the wall. This wall takes 3 plate at 10'8" and 6 92 1/4 studs, or 20 90 1/4 studs. and just give you that information so you can just go ahead and build. But either way, someone's got to determine long and short and the layout and that kind of stuff. Any questions about that? Let me go to this is just a taste. There's a lot more in this, but it's not part of what this class is about. So let's go through review and see what I've got for problems to make sure that this stuff makes sense in lieu of that. Okay?
Mhm.
Zach, you okay?
I sure hope so.
It's hot today, huh?
Little bit.
You know, it varies. Goleta, anybody live in Goleta? Goleta wasn't too bad, you know. I don't know if it was hot. By the school, it was hot, right?
Yeah, like off the terrace there.
Yeah. Yeah, even Goleta varies. I'm close enough to the beach where I am that some of you have been in my house, that I get a lot of, I'm getting fog now, which is kind of nice on the hot days. It goes back and forth, clear and fog, but I'm like, oh, this is great. And every few years it's different. Some years we don't get any fog. Some years we get tremendous wind. I mean, this place is so varied. It's kind of what makes it nice.
I was living in Jubilee yesterday and it was so foggy, and today it's so sunny. I'm like,
Oh, yeah,
Tomorrow's gonna be cold too.
yeah. No figuring it out ahead of time. And the weather reports are always wrong for Goleta.
I know, I looked at the weather today, it was like 65. That's so false.
So cold.
It was like 80.
down here to Goleta.
Yeah,
Over there by the tunnel, like,
yeah,
it's like you see the fog. Like
Yeah.
They put in the fog. and
yeah.
go in.
Yeah, you could see it along the whole coast, right? Just on the beach, didn't come in very much. Kind of cool. How hot was it in San Ynez?
Like 90.
Who had 100, 102? Oh, no, a friend of mine. America was 102.
Try 114
Where was that?
between Las Vegas and Mesquite.
You live there?
I was on a trip and I was driving back.
Yeah. Oh, those aren't nothing. Under 120 is nothing anymore. It's gonna start rising. Okay. So the first question is 4 parts, and I'll have the material on one side. And I can tell you the material: baseboard, sheathing ply, roof shingles, and concrete.
Say that one more time?
Baseboard, sheathing, roof shingles, and concrete. And then next one, I'm going to have unit. So, and then you're going to draw a line across from each one to the unit, appropriate unit. So the units, so let me go through the units, even though this will, well, it won't be given away. But if something you order, like a piece of wood, like a stud, you call that it's a piece, right? So you order by the piece, like 150 studs. So it's a count. Plywood, you also order by the piece, right? 50 sheets of plywood. So if you can count them, 1, 2, 3, then it's a piece of it. Linear foot, it means the total length. So baseboard is usually, used to be, it varies now, it's ordered by linear feet. So you just count up you add up all the feet in the house, 525 linear feet. And that's how much baseboard you get. And the lumber company just gives you what 525, whatever lengths they have. If you don't want any waste, usually a good carpenter can figure it out so there's not a lot of waste. You have to sort of sit down and figure out where your walls are. You can also join base, so it's not the end of the world. You're not going to always have whole pieces. If you want to do it more exact, it just takes more time in the ordering. You have to actually go with each wall and say you can get 20-foot long pieces. You can get 10, 12, 14, 16, 20 pieces. Then you just have to put those lengths down, the the lumberyard gives, and put each of your walls under that.
This for the test review.
Pardon?
Is this for the test review?
Yeah. So by the piece, some things were by, if they're ordered, so you can count them, 1, 2, 3, it's by the piece. If they're ordered by the total length, it's called linear feet. If they're roofing, it's called, what do we say?
Squares.
Squares. So roofing's ordered in squares, and concrete's ordered in what?
Cubic feet or cubic yards.
Cubic feet or cubic yards. Okay, so you pretty much got that. You just have to connect the dots. Okay, other one, I have a shed roof, 10 feet by 100 feet. How many squares? A roof 10 foot by 100 feet. How many squares will you need for that? How many squares of shingle? I have a, oh, here's the perimeter one. It's a 100-foot perimeter, so you don't even need to add it up. You know, when I put 20 by 30, I used to do that, and people wouldn't add the other two sides. So they'd put 50 down. So in the math class, I would tell people this. I'd say, when you get a problem like that, always fill in all the sides, like fill in the other 20 and the other 30, so that you're staring at all four. When you go to add it up, your mind will go to that. It's just a trick so you won't make a mistake. I mean, some of us can realize we're doubling it, but. So it's a 100-foot perimeter, and it's just a square foundation, 1 foot high and 1 foot wide. So how many square feet is that cross section of that foundation? 1 foot high and 1 feet wide. One times 1 is 1. And then it's 100 linear feet.
100.
So it's 1 times 100. And I say, don't worry about overlap at corners. So for that perimeter problem, you want to multiply the perimeter times the area. The perimeter I give you, and I give you the length and width of the area. So you just have to multiply those, the 1 by times 1 times the perimeter. Okay?
What was the question before?
The shed, how many squares will take for a 10 by 100 foot roof? So you multiply, you get the area of the roof and divide by 100. Yes.
Are you recording in classes?
Yes. You should be.
Are you saying recording? Yeah, you're recording.
Thought I did. God, it scared me. Thanks for the double check. I would have to go back over it because there's guys who couldn't make it tonight. I have to stay late to process it all so they get it. Oh, is anybody going? Did someone take Tyler? Who took Tyler home last time from here? Can you do it again tonight?
Yeah.
Okay, because I have to stay and do the recording. I take it. What? Oh, okay, great, thank you. Yeah, I promised Lewis that I would. Usually I wait till I just leave it and it has to, what do they call it, process the recording. And then I come back the next day. But since the finals were on, I told him I'd do it tonight and get it out. So you can study from midnight to 6 tomorrow. He won't need to study. Okay, so so number 6 asks for how many square feet of concrete. Number 7 is going to ask for how many cubic yards is that equivalent to.
And can you repeat the sheeting and the shingles
Yeah,
part? I did not.
yeah. So roofs, the roof measurement, it's a special measurement. It's called a square, and it's 100 square feet. So you want to find out how many 100 square feet areas you have in your roof, and that's how many squares you'll order. So the area of a roof, if it's 10 by 100 feet, the area will be 10 times 100. And then you'll divide that by 100 because 100 square feet equals a square. You can do it in your head, looking at it, or you can multiply it out the long way if you need to do that. Yeah. Yeah. The 7th one refers to the 6th problem, which was how many cubic feet was in that how many square feet was in that foundation? Was number 6. Number 7 is how many cubic feet would be in that foundation. How would you change that cubic feet to cubic yards? Sorry. Yeah. Remember, it's the 27. You know how you can remember 27? I have trouble with those kind of numbers. So what I always tell people is you draw a cube. Well, you got to know how to draw a cube or you won't screw with that thing, right? And then you just put, it's 3 wide, 3 high, and 3 deep. So 3 times 3 is 9, times 3 is 27. And the same thing for the square cubic foot. How many inches in a cubic foot? So this is 12 by 12 by 12. So it's 144 times 12. I can never remember what that answer is.
Zach?
Zach? We're racing.
Looking. 1728.
Get that
1728.
in your head?
No, I'm using Google.
I was gonna say.
Yeah, I didn't do any of these in my head. I used Google on all of them.
1728. Yeah, who can remember that, right?
There's
I-
no reason to.
I've been teaching this class for 15 years and I still can't remember. I have to multiply it out to remember. Those kind of numbers don't mean anything to me, right? 144, you know, because when you learn your tables, you kind of remember that sometimes. But 1728, you won't need to know that for this. Sometimes there's, you know, you might want to do, you'll be doing inches and feet, but none of these problems involve that. But I was just telling you how to find out those conversions. Just draw a cube and it'll tell you how many feet or inches are in a cube, that cubic measurement. Okay, 2 most common types of foundations in Santa Barbara. We talked about that, right?
7 race.
Everybody knows a slab. What's the other one?
All space.
Raised foundation. God, I'm giving all these answers away. Okay. So I'm going to ask you one about what materials you need in a stem footing or upside down T, they call it sometimes. Foundation. Remember I asked you how many materials went into a wall in the last test?
Mhm.
I'm going to ask you a similar one. In the book, they draw it like that. They used to pour this, and then they have a, and then they must have done it like this. All the books have this. It's a little notch, so that they would pour the footing first, and they put a board in to make a notch. And then when they poured this, the concrete would go down into it, and that would keep it from going this way. But an earthquake, that's like nothing. So they don't just pour it all at once. Yeah, they either pour one or they pour it with rebar. And they pour the second one's got a lot of rebar glued together. But anyway, so okay, so you'll need rebar.
What about those like tie down, metal tie down to wrap the rebar?
Okay, let's see what it says. For a typical footing, stem wall, foundation, what materials we need? Okay, that would be optional. You could put that tie down, or you could put just a anchor bolt. So you'd have form boards, right? Say wooden form boards. You'd have an anchor bolt, concrete, rebar, anything else you can think of. That's mostly it. There's a few other things. What?
Wafer.
No, but I see materials. But you know, we used to just go back and put the anchor bolts in by hand in the old days. You know, when the dinosaurs were running around. And then we put a bolt in. You wait till the cement was just a certain thickness, and then you shove it in so it wouldn't sink. But they don't let us use our own initiative anymore. Now you have those little plastic things that set them in. They're actually better anyway. God, you get all the creativity out of building. It's probably safer, I guess. All right. So far, so good. In a house that has indoor plumbing, What systems are in the water distribution? No, wait. What two or three systems will there be? Plumbing systems.
Waste.
Wastewater vent.
No, just in the, yeah. Okay. DWV, right? No. What is it? Waste. Oh, yeah, DWV. DWV, it was one system, and water system, and possibly a gas system, right? That isn't a question, but if you know that, you'll be able to answer the question. Those are the only three that are standard.
But it could be just like potable water, wastewater, and gas. I mean, does that count also? Or?
Yeah. Then I'm gonna have, my question is gonna be true or false. I'm gonna name some systems. You have to see if those systems all check. Then DWV, I'm gonna ask what that stands for. I'm gonna ask why vent stacks are needed. So when a house has a slab, or an office or a commercial building has a slab foundation, when does the plumbing work start?
Before pouring the concrete.
Yeah, because you got to get it through the slab somehow.
What was the question before?
Vent stacks?
Yeah, what was?
Why do we need vent stacks? Then I asked for what does HVAC stand for? Now, so here I say, what does HVAC stand for? So you don't have to even tell what it is. Then I want you to name two types of space heating systems.
What was that?
Two types of space heating systems. So you don't hear the word space heating a lot because they just say heating, but there is water heating, right?
Is
So
water
technically-
heating on that?
No.
Or just space heating?
Just space heating. And then know what circuits go between. What circuits connect the panel or something, two other things.
Plugs and switches.
Go ahead.
Plugs and switches.
Out, did you say outlets?
Yeah, outlets, outlet plug, yes.
Yeah. Some switches. And when did we use, when do they use fuses?
Before circuit breakers.
Before circuit breakers, yes. Thank you. That was a good answer. That's the shortest answer you can give. That's great. Remember, it used to be fuses, and then now we use circuit breakers.
So before the,
What's that?
before the fuses. What if I could-
We use fuses before circuit breakers. Okay, GFCI, know what those are?
The ground fault.
Yeah, I tell you what it is, and you have to answer true or false.
Okay.
Now, remember we studied things called schedules, type of print called a schedule? And it wasn't a sequence of time, right? Usually schedules are, what's your schedule? Well, Monday I go to the dentist and Wednesday. So it's a deviation from that. Usually. That can be confusing, not to you guys. And then a window schedule, I'm going to ask what kind of information that would contain. So you can go to your plans will be here, or you can go to a handout and look at a window schedule. And then I'm going to ask you what specifications are.
Say that again. I didn't
I'm going to ask you about specifications
Uh-huh.
and what their legal status is specifically. Oh, here's one. I don't think I can't remember if we talked about it or not. What is the main purpose of the building code? It's a good thing to question, right? So there's a bunch of purposes, obviously. So let me tell you what I think the main one is. Safety. Citizen safety. Because mostly, if you look at the state building code on the internet, or if you're rich enough to buy a set, most everything's oriented toward fire. Because we've had some bad fires from electrical, from
The Thomas fire was electrical.
yeah, electrical or building, something with a building. So, and commercial buildings are really bad too. And they've had fires in factories, over the years. So the building departments are really sort of obsessed with that.
Or the car that. No, fire.
And I mean, you could say safety in general, fire safety, and like when they have restrictions on stair heights because they figure large stairs aren't safe for older people or whatever. They're always, a lot of their dimensions are based on what makes sense for most people's safety. That's the only justification they have, really.
It comes out there for the safety.
Because other than safety, they have no business telling you how to build. It should be your own business. But if you believe in a state, in a government that we need a government to run things, then that's what we do. Most people would rather build their own houses whether they were safe or not. Let's face it. I mean, you got to be pretty dumb to build a totally unsafe house. I mean, even just as a human being that's been alive a few years, you know what weights. Well, I know. You could probably document and prove me wrong totally, but you go to like in most cities, there's an equal population in the slums outside the cities as there are in the cities. I just read that somewhere. And the slums are totally self-built. The government won't even go to them, right? They're dangerous and they don't want to be involved. And you rarely hear of any safety problem happening. Well, we don't hear about it, period.
Hear about it.
Yeah. We hear about the drug raids and all that stuff and the gunfights, but we don't hear about that. But people are smarter than you think, especially people in third world countries. I think Americans are pretty stupid. But in Europe and older countries, people have a lot of savvy when it comes, making things. In the country we do. I lived in Maine, in the country, for 10 years, and I was surprised at how smart people were about building and just everything. It's pretty interesting. They just value a different kind of smart. The city people are usually, we have an occupation that kind of takes over our being, and we're smart about that. We learn all about that, but we don't know a lot about anything else. So hopefully we can get those two together someday. Okay, electric circuit pathways. I'm going to ask you if those are shown on the plans or not. But don't answer that. We've talked about it. You can look at a plan. It would be on a floor plan. And by pathways, by circuit pathways, I mean the Romex, where the Romex actually goes, not the connection to a switch and the light. That's not a real material connection. That's just an idea. Fine, okay. Here's a question. Don't answer it. I'm going to give you a question. In residential floor plans, the architect locates electrical receptacles and switches where they will be convenient to residents. That's true. I'll tell you that. Because I'm too lazy to explain it. But the architect does do that. That's part of what the architect does, is make the house convenient for the dweller. Now, that doesn't mean the architect can ignore the codes. So it's really the architect and the building department that are designing the plumbing, but the architect places things where they need to go. That's something people could do too, right? You know, you don't need an architect to build your house, right? To design your house, right? You can draw the plans yourself and turn it in, and they might say to have a structural engineer confirm some of the building parts. But they would do that for anybody. They would do that for an architect. An architect would probably do that ahead of time. A lot of people don't know that think that you can't do it by yourself, but you can. If you want. Same thing with plumbing pipe. Are they shown on floor plans? The pathways of the pipe? And again, you can go to a floor plan, see if you can find a plumbing pipe pathway somewhere. And here's a corresponding question that one about architects. The architect leaves the location of plumbing fixtures up to the plumber. Okay, that's false. You might think because the plumber is the expert in his field, but he's not the expert in design. He's the expert in function. Okay, then I want you to name 4 plumbing fixtures. Fixtures.
Yeah.
4 plumbing fixtures, and just in your plumbing, well, you could Google that, but in your plumbing handouts, I'll have Bill talk about it. Name at least 3 types of inspections during the building sequence. There's a ton of them, so you should be able to get 3. Just think about it. Name 3 types of inspections. There's a whole series of inspections. So just think about how a house is built. You know, the sequence follows the covering up of something always. So they're going to inspect the framing, obviously, because that's going to hold the house up. So if you put sheetrock on it, they can't see the frame. So there's going to be a framing inspection before the sheetrock goes on. And same with electrical and plumbing. I mean, I'm just giving it away, but they go in the wall and you can't cover that up until the electrical inspector comes out, because you have to see how the circuit, how everything's run. So everything kind of follows.
As far as the inspections go, are you stuck with one inspector or there are several inspectors?
Well, I think there's the electrical and plumbing are different than the building, than the, I don't know what they call it.
I think you have various
Frame.
inspectors of the city.
Well, when I did the most recent thing I did was I told you I did a balcony on my house in Goleta, under Goleta auspices, Goleta City. And the one inspector did everything. Framing, stucco, drywall, electrical, there's no plumbing. cheated everything. If it's a, I mean, I have, one outside outlet and a switch and a light fixture. So they could do it. I imagine if the electrical was complicated, like in a commercial building or a really fancy resident, they might have electrical inspector go. Circuits are only electrical pathways, right? Building, that's the words reserved, just electrical. So there, we gave a name to where the electricity enters the home. Don't say it out loud. But it's got its own special name where it comes off the wires. What is the name of the, well, it's a true and false. I give you a name where the electricity enters the home. And I say on the grid because solar would be the same thing, but that word's not as established because solar's so new. So GFCI is used in what kind of places? What? Yeah, and what circumstances?
Where water.
Where it could get wet, yeah. A GFCI. And the distribution panel, remember we said it had different names. What does it have in it?
Breakers.
Yes, circuit breakers. Among a few other things. And we said, what were the main types of plumbing pipes used in Santa Barbara?
Like the material.
Piping materials.
Do we say them right now? No.
Yeah, PEX was one of them, right? PEX.
Plumbing materials.
Santa Barbara, the main ones for supply. No, supply is only going to be copper and PEX. Yeah, drain will be black stuff, ABS. Or,
For water supply, you're saying, like that question.
yeah. And I think I have on. So 37, I mean, one of the questions I have, plumbing fixtures are shown on the floor plan, true or false? So most plumbing fixtures are shown on floor plan, except for a faucet. I just realized that they may not show a faucet. They may show the location of it, the hole, but they don't actually, like they'll show a sink. But they may not show faucets. So just the bigger ones. Because you could say, well, this one isn't showing. Huh?
That was true.
So, and drain pipe is the black plastic or the white plastic? You have to figure out the names, but it's true and false. And then the main heating system, probably in Santa Barbara. What do you think?
Either gas or electric, you mean, or?
Yeah, gas. It's usually gas, forced air. I'm pretty sure that's the leading one. What else would it be? And what's involved? What are the components of a forced air heater?
Furnace,
Furnace to heat the stuff.
thermostat,
Thermostat, yeah, to control it.
the conduits or conductors or the piping.
Duct- Ductwork, yeah, okay. And we talked about heat pumps as coming kind of the latest thing. Okay, here's a question. Remember we said electricians, they don't really have a plan. They have the switches and the outlets on the floor plan, and that's it. And then plumbing plans are sometimes, I remember on that handout, they were isometric. Those are the ones that were at a 30-degree angle. So I ask, why are they drawn that way sometimes?
Oh, okay. The drawing themselves.
Yeah,
right?
why do why are some plumbing plans drawn as an isometric drawing? Then I ask, why do you need traps? Plumbing traps? Why do we need traps beneath sinks and tubs? Oh, boy, I think I have this question twice. I do. Oh, well. I have a question twice, just answer it the same way. Oh, I'm going to ask you a question about hydronic space system, space heating system. Remember what that was?
Five sort of room with hot water.
Yeah. Then I'm going to ask you approximately how many studs, 2x4 studs are there in the exterior wall of a certain size building? So you're going to add up the
Which is
perimeter.
what we saw just now.
No, you're going to add up the perimeter. And then you're going to, and then you're going to take that as feet, right? And then you're going to take one stud per foot. Is that what you were saying?
I was saying that if it's what we just studied.
Well, that was the foundation though, right?
No, I mean, like today.
Oh, yeah,
before
yeah,
you.
yeah.
One stud per foot.
Yeah. And then on a 2-foot center, how many studs are there in an 8-foot long wall? I think we did that. And on 16-foot center, how many studs are in a 12-foot wall? Oh, that's a good question. What'd you say, 13?
Yeah.
Yeah, by the 1 per foot. Yeah,
13.
yeah. So what's 12 times 1,244 divided by 16? What?
9.
And then there'd be one more, so 10. So between 10 and 12. You can draw that out. So if the wall didn't have any windows in it, it would be 10. And if you did a foot per stud, it would be 12. So either answer would be okay. Thanks for noting that. I had in mind one of those systems, but you can figure either way. And then I asked a question, what do you need to know about the position of exterior walls in order to build them to the right length?
Did you get the question?
Yeah, what do you need to know about the position of exterior walls in order to build them to the right length? You have to know whether they're long or short, right? So when you have a set of plans and you've got a living room and you want to measure the walls to build them, you can't, the ends are going to be like,
Or it's gonna be longer than the other.
yeah. So you have to know which ones overlap. Okay. So that's basically it, like we talked about.
Mhm.
That's it. How easy is that?
Not easy. Yeah,
Okay.
3 hours.
Yeah. wow, we got done early. I'll be here. Bring your notes, and the plans will be accessible. And you can come up and ask me questions if you need clarification. What do you think? So, we were going to plan the party. It's not my idea. Lewis wants to have a party the day after the review of the final.
How many going away parties are you going out?
I know.
I think it's
Well, it makes up for the fact that I never have any class parties.
Yeah.
Patrick, it's important to note that this might be your last class, though. It's not final.
That's what he says every time, Tyler.
Well, I don't know. It is every time.
You should assume that it is and make it even bigger.
I know. Well, it wasn't my idea. It was Lewis's idea. But
Lewis is a big partier.
I know he is. So, and he's a good buddy. So I'll do it. That's fun, right? So it's at 6, right? I mean, we'll do the review. That won't take very long. But what if people eat at 6? I mean, do you guys eat before you come here? Do you eat dinner before?
I mean, if I'm getting a food, I don't eat before.
So you want food, not just treats. So I'll get a couple of pizzas, and then
I'm not having it tomorrow.
I know, he mentioned Costco pizza.
Costco pizza is great.
So good.
I know, but like a couple days in a row.
Stop eating it.
You'll feel different about that.
That's true.
Just stop eating it.
That's funny.
Hey, Patrick, so summer two, is that a no-go?
It's a no-go. We kept it, what was it, 6
Is Rodney?
forever. It never changed. And I sent out a note to, students that were in the last class. Some of them wanted to take it. I didn't hear back. I got pressure from my chair. He said, and we've got 4 from that had signed up for the fall one, but I didn't know. Tyler was one.
Yeah, I'm not able to I wouldn't have been able to do the summer school. I would have had to do it fall.
Yeah. So, and I couldn't find out who those were to talk to them, but even with 4, that's still only 10. We need 5 more. So my chair said,
Did it automatically take it off?
Yeah.
And should I just add the fall?
yeah, so go ahead and register for the fall one.
So register for the fall.
Yeah, there's plenty of room, so you don't have to worry about it, but yeah. And I don't know who's going to teach it. Like I said, we haven't met with this chair yet. He signed the contract, so he's hooked. We got our claws in him now. But we have to, the dean's got to tell us how many classes we can offer, and then how many he's going to take, because he has full-time, has to have a minimum number of units. And then if there's units left, it'll probably depend on the class. If he doesn't want it, it'll probably depend on the class he doesn't want to teach. So there's 124, which is building performance. I mean, he's smart enough, he could, bone up and do any of them, but he may not want to do that. He may not want to do the math. I don't know. And then I got to arm wrestle with Rodney about it, because he wanted to teach him. He can, I don't know. I'd let him do the math. I think I do a better job. But he likes to do it. And the 124, but a lot of you guys have had the 124 already, right?
What is that?
The building performance?
Probably.
I'm in it, yeah.
No, but you haven't had it before, right?
No.
Yeah, so there's a outside possibility I could teach either of those, but we don't know. We have to meet, hash it all out.
Do you know if there's going to be any non-credit?
Well,
Probably not.
Jim, have you looked on the website?
No, I just remember I don't know if it was last spring or fall, but they didn't match up. It would like be when Rodney's class was in session and Jim was having a non-credit one, so it didn't make sense or something.
Yeah, well, last time I talked to Jim, he said he was gonna do a non-credit and credit if he was needed for fall and not teach in spring. But I don't know if that's still what he's thinking. I'll find out. I can find out. I'll call him tonight or
Yeah,
tomorrow.
because if there's like the non-credit electrical or whatever he used to do, that'd be great.
Oh, I'm gonna take that non-credit like a school class.
Well, yeah, I mean, Rodney could probably teach it too. And I told Rodney if all the credit classes were taken by the full time, that's not good to have one teacher. I mean, I did it for 5 years before I had enough classes to hire adjuncts. But it's really nice to have people you can bounce off of, colleagues, you know. And so I hope there's room for at least one or two. Like when I was chair, Rodney and Jim both worked, so there must have been room for 2 each time. So probably we offered more classes. That's what we're going to find out if we can do it. And that'll depend on if we can fill them or not. But I think what we should do is offer them, and if they don't fill, just move them to the next semester, but at least offer them, because maybe they will fulfill. And then people could take a lot if they wanted to and buzz through here faster. We'll see. Yeah.
So are we bringing anything else besides the pizza? Like,
Oh, yeah.
some drinks?
Well, he wanted to divide it up, but I guess I wouldn't have to do it all. But does anybody feel like bringing anything? Anybody got any specialties?
I can bring some soda.
I'll bring it over.
Drinks and, you know, sweets like dessert. Because some people may eat and then not be hungry for something like pizza, but wouldn't mind some cookies or. What do you think?
It's something for Man's Bakery staff.
Well,
Good to candy.
you know, Lewis talked about a cake. I don't know if he was kidding or not. I'm so awkward. You know, when it's a party, when it's your party, you know, you
Yeah,
don't
we
want to
wanna
like
make a cake
ask
out
for
of a
it.
house.
I'm serious about that.
What's that?
Boots was one time for bakery.
A house cake.
He sounded pretty excited about a cake. So maybe that's all we need. I don't know.
Yeah.
But just remember, if you buy anything for the party, you can take it home if nobody eats it. Or whatever's left. So it's not a total loss.
I'll bring sodas.
Or a cake contest.
All right. So, so is everybody, I mean, the finals tomorrow, right? Is everybody,
I feel like we just started the class.
yeah, you know, even if we'd gone longer each night, it still would feel short. You know?
Yeah.
We'd be more tired, but just,
Probably because they have like two days in a row instead of like spread out.
yeah. Well, and then we did Monday, so we got two holidays. I mean, that's both good and bad. Right? The students always seem to like the holidays no matter what, you know. That's because they got other stuff. They get either working or they got family obligations or they're taking other classes. So non-classes is always good. Okay, so I guess that's it, right? What's that?
Restroom.
Once you go to the restroom. Once you go to the restroom.
Oh. He's got, his voice is always hard for me to hear. Certain frequencies are harder. I gotta get here maybe. Keep putting it off. If I couldn't hear it all, I'd just go out in the hearing, but I can hear like 2/3 of what's coming in. So. Okay, let's go home, huh?
All right.
Okay, Zach, did you get everything on there?
Yeah, I did. Thank you, Patrick.
Okay, you're welcome. And, I'll be here tomorrow and I'll have the Zoom going, so I'll probably send you the test tonight or in the morning.
Mhm.
And then, okay, you guys, and then, if you got questions, I'll be here tonight with the class with Zoom, okay?
Okay, sounds good. Thank you.
I will.
Okay, bye.
Bye-bye.